let's have a look at some further examples involving indices. And I've chosen 4 examples that are a little bit more involved. So let's have a look at the first one. So we're going to simplify the 4th root of 81a squared to the power of 3. So what I'm going to start off by doing is just going to leave the surd where it is. Okay, so the 4th root, as you know with index laws, that means raising to the power of 1/4. We'll get to that later. So that's going to be 81 cubed multiplied by a to the 6. So this is the power to a power law. Now we're applying law number 3. Now we can separate the surd into the product of 2 surds. So that's the 4th root of 81 cubed multiplied by the 4th root of a to the 6. Okay. Now the 4th root means raising to the power of 1/4. So that's just 81 cubed to the power of 1/4 multiplied by a to the 6 raised to the power of 1/4. Now 81 cubed is fairly difficult to work out, but 81 to the power of 1/4, that's just the 4th root of 81. The 4th root is really the square root of the square root of. Okay, it's another good way to put it. In fact, it's sort of nice to note this one, in fact. So this is really the same as saying, right, 4th root of 81 all cubed. So I've reversed the 3 and the 1/4 around, and I've used surd form here to express that. And that's multiplied by a to the power of 6 on 4, which is 3 over 2. So I could leave that alone there. In fact, I don't have to do anything with the pronumeral. But the 4th root of 81 is really just the square root of the square root of 81. So square root of 81 is 9, square root of 9 is 3. So that's in fact 3 to the power of 3 times a to the 3 on 2. And that's equal to, in fact, I've just run out of space there. So that's equal to 27. Okay, a to the 3 over 2. If you want to go one step further and express it in surd form, perhaps, that's really just 27 a root a. Why would that be? Okay, so I'll leave you to think about that one. Why is a to the 3 on 2 the same as a root a? Okay, think of index law perhaps number 1. All right, multiplying 2 terms with the same base to give you 3 on 2. Right, next one. 128 x to the 4, all to the power of negative 3 on 7. Okay. So we now have a fractional index, and it's also negative as well. So this implies that it's going to be perhaps some sort of a fraction, or a reciprocal. In fact, this negative here implies reciprocal. Okay. So this is really 1 over, okay, so 128 x to the 4. Okay, now that's the power of 3 over 7. Okay, so I'm going to raise it to the power of 1 on 7 first, and then I'm going to raise it to the power of 3. And I've chosen this order for a reason. Okay, have a think about it. 128 to the power of 1 on 7. That's the 7th root. Okay, the 7th root of 128 is 2. 2 times 2 times 2 times 2, so on and so on. 7 of them together, if you multiply them together, you get 128. Okay, so that's going to be equal to 1 over. So I'm going to apply now this raising to the power of 1 on 7. So that's going to be 2x to the 4 on 7, all to the power of 3. So we're only working with the denominator now. Don't worry about the numerator. So 2 to the power of 3, that's equal to 8. So it's 1 over 2 to the power of 3 is 8. X to the power of 4 on 7, all to the power of 3. You multiply the indices. So that's going to be x to the 12 on 7. Okay. So this is part B expressed with a positive index. Okay, so if you're ever asked to express this with a positive index, we've got to take this negative and turn it into a reciprocal. All right, let's have a look at two other examples. Okay. So what do you think about this one here? This is x to the power of -1 plus y to the power of -1 all to the power of -1. Okay, so I'll leave you have a think about that for a moment. So clearly this is really a whole bunch of reciprocals, isn't it? Okay, so expressing this with a positive index. Okay, let's see what's going on here. So this is really just 1 on x plus 1 on y to the power of -1. So this is 1 over 1 on x plus 1 on y. Okay. We can't add two fractions together unless the denominators are common. So if we multiply the second fraction by x over x and multiply the first fraction by y over y, okay, hopefully we can do something with this denominator, not have this situation of fractions inside a bigger fraction. Okay, so this is 1 over, okay, y on xy plus x on xy, which is just, well, we can combine the fractions together now because it's a common denominator. So this is x plus y over xy. 1 over all that just means take the reciprocal again. Okay, so this one is just xy over x plus y. Okay, and the last one. Okay, so this is looks like the negative third root of 27a to the -1. Okay, so I chose this example just so that I could show you what the root of a -3, in fact, what that means. So the negative third root, in other words. And it means exactly that. It's just, rather than raising to the power of 1 on 3, you're raising to the power of -1 on 3. So this really could be written as 27a to the -1 all to the power of -1/3. Okay. So yes, it is possible to have this a surd symbol and the order of the root, whether it's a third, fourth, fifth, can be a negative number. Okay. So that's just 1 over, okay, 27a to the -1 to the power of 1 on 3. Okay. So that's a cube root. Okay. Cube root of 27 is 3. Okay. And you got also a to the -1 to the power of 1 on 3 as well. So let's expand the bracket. So that's going to be cube root of 27, which is 3. And then we have a to the -1 on 3. Okay, we're not done yet because we still have really a fraction inside a fraction. You've got this -1 on 3. Okay, so that's just 1 on 3. So I'm going to separate this fraction now into two fractions multiplied by 1 over a to the -1 on 3. -1 on 3 implies a reciprocal, but there's a reciprocal already. So this is really to the power of -1, isn't it? So I'm going to run out of space here. Hopefully I might have enough. So that's multiplied by a to the -1 on 3 to the -1. Okay, so this 1 over is represented by a power to the -1. Okay, so that's 1 over 3 multiplied by a to the 1/3. I might just do the answer here in a different color. And we can express this in a fraction. So this is really, okay, the cube root of a over 3.